Once we have analyzed the threat asset pairs and the mitigation option that we're looking at, we can now move on to step 7, which is risk and resiliency management. And this can be here in the benefit cost ratio tab. We can see here there is a row for no action and a row for mitigation. It should be noted that a lot of the cells here in the benefit cost ratio tab need to be updated. It is not automated. So for the no action row, the owner risk, we will have to pull that data from our flood bridge existing tab. And that's the data that we pull from step 6. So it should be $746. And we can link the cells if that makes it easier. We'll also have to update user risk. This total risk should match the total annual risk that was calculated in the flood bridge existing tab, which it does. Next, we want to link the information for the mitigation tab. We can see that the risk associated with the mitigation option is lower than the existing condition asset, which is the bridge in this case. So upsizing the bridge would result in less risks than leaving the bridge as is today. And that makes sense. Next, we want to move to the average mitigation benefit. This actually pulls data over here, so there's nothing to update. It's really just a difference between the risk associated with no action and mitigation. So we can see that there's a difference of about $26,000 between our flood bridge in existing conditions and our mitigation flood bridge of upsizing the bridge size. And then we'll come to the mitigation cost analysis tool. This is where we can look at the actual replacement cost, or ARC. We will need to link this value as well. So the cost of asset replacement is the no action tab that I'm going to look at. And I'll scroll down to cell C110, and then the cost of new mitigation. So because our new mitigation looks at upsizing the bridge, it makes sense that it's more expensive than the cost of replacing the bridge in kind. We can also update the lifespan of mitigation. For a bridge, I like to estimate about 80 years of lifespan, and for a culvert, I like to do about 100. This then updates the mitigation annual costs. This looks at the cost of the mitigation over the lifespan of that mitigation option. So if we're replacing the existing bridge with a bigger bridge, how much will that cost over the lifespan of that bridge? And that will cost CDOT about $62,000 a year. Next, we'll move to the benefit cost ratio tool. These ratios can be used to compare the mitigation cost versus the risk associated with no action and mitigation. So even though this mitigation option costs a little bit more, we are reducing the risk associated at this location, which can be a big benefit to CDOT and the public who are using our roadways. It should be noted that in some instances, the mitigation cost analysis will actually result in a lower cost than the asset replacement. So sometimes the mitigation costs less and results in less risks. This is really a win-win analysis. In this case, you don't need the benefit cost ratios because the mitigation cost is less than the cost of replacing in kind. This is a great situation, and it does happen. So be on the lookout for mitigation options that save money and result in greater resiliency for CDOT.